Welcome everyone to the next installment of VELP Scientifica's webinar series. I'm going to wait a few more moments for people to come in, make sure everybody's able to get in the webinar, and then we can start. All right, well, thank you everybody again for joining us on this next installment of the VELP Scientifica webinar series. Today we're going to be going over exploring the benefits of hot solvent extraction and then how that can affect and improve your laboratory workflow. So I wanted to quickly go over the agenda. And first off, there we go. First off in the agenda, we'll have an introduction to our solvent extraction series and more about the actual technical aspects behind it. We'll then move into the VELP SER 158 series and some of the benefits of our system. We'll then go over some of the main applications and look at results for different applications across various food and agricultural and other industries. And finally, then we'll do a demo from the VELP lab with my colleague Paola Ornaghi. My name is Corey Letizio, and I am the VELP Inc. National Sales Manager for the United States. And like I mentioned before, I'll also be joined by Paola Ornaghi. She is our VELP Analytical Department Manager. And always, if you have any questions during the webinar, we will answer them at the end, but you can feel free to type them in the box on the right-hand part of your screen. So let's go quickly over VELP Scientifica. Now, VELP Scientifica was established in 1983, and it's been privately owned by the same family since inception. Our headquarters and manufacturing are in Italy, and they're about 30 kilometers north of the Milan area. VELP Scientific Inc. is a subsidiary that I'm a part of. We're based out of Long Island, New York. We provide sales, service, and analytical support to our North American market. We also have VELP China Company, and they were established in 2019, and they provide sales and support to the greater China market. And we also have representative offices in South America and India to provide support where needed. Now let's briefly go over the product portfolio. We have two different lines here at VELP. We'll be focusing today on the analytical instrumentation line and specifically our solvent extraction series. But as you can see, there are other different instruments for protein, fiber, and oxidative stability reaction. And in addition to this, we have laboratory equipment that can be overhead stirrers, BOD, respirometers, circulating baths, and things of that nature. And before we get into the SER 158 in itself, I always like to mention going over our service and application support that we provide here in North America. And the obvious mission of this is to ensure that your instrument is running and guaranteeing peace of mind and has as little downtime as possible so you're able to focus on your lab work. So some of the ways we do this is through our help desk and remote support. We do this through application support, so defining specific applications for needs and applications for different areas such as fats, fibers, and proteins. We then have technical assistance, and we have installation and training. And this is where one of our VELP service technicians can actually come on site and provide installation as well as training. And they can also be on site for our preventative maintenance options. And finally, we also offer calibration certification to ensure your instrument is running at its desired optimal level. So now let's move into the solvent extraction side and give you a little introduction to solvent extraction for those that aren't familiar. So solvent extraction is a method performed where separation of mixtures is used in different solubility of components. So many of you guys may have seen this before with fat extractions, separations of different things in textiles and fibers. And specifically today, I want to talk about solid liquid extraction. And this is what allows soluble components to be removed from solids using a liquid solvent. Again, whether that's PET ether, diethyl ether, something like that, to remove solvents with a liquid solvent. Or sorry, removing solids with a liquid solvent. And with this, there's always officially approved methods, as this is a primary method. And this solvent extraction is approved by most important official worldwide organizations and bodies. Examples of this in the United States are the AOCS, the EPA, ASTM, but there are also other worldwide organizations that have officially approved this method. So in extraction techniques, there are three main ones that I want to focus on today. First is the traditional Soxhlet method. And this uses a cold solvent and will oftentimes take a long time due to the solvent not being warm. The solvent passes through the thimble, and oftentimes this will also be known as goldfish, and it's going to have a lower solvent consumption than the traditional Soxhlet method. Now, what we're going to focus on specifically today is the Randall or hot extraction method. And this occurs by immersing the thimble into boiling solvent to optimize speed and solvent consumption. And this is also known as accelerated Soxhlet. And we'll explain in a little bit more detail why this is much more preferable than traditional Soxhlet. And we also have a method for Twisselman, and that is hot extraction with the solvent flowing through the sample in the thimble. And this is something that's also available on our SCR 158. So like I mentioned, there are some hot solvent extraction benefits compared to the Soxhlet method. Now, the application range, repeatability, and reliability are all going to be the same for traditional Soxhlet versus hot extraction. Some of the main differences and benefits with hot extraction is going to be a rapid extraction. So it can be up to 5 times faster depending on your application. And low solvent consumption, and this is due to some solvent recovery. So in traditional Soxhlet, you don't recover much solvent at all. With hot extraction, you can go 90–95% of solvent recovered per analysis, which leads to cost savings over a period of time. So now let's move into the VELP SCR 158 Automatic Solvent Extraction series. So as you can see from this picture, we have 2 different models. We have our 3-position and our 6-position. And what you can see from this is that they are very compact, and if it needs to be under a fume hood, you're able to do so. Now, you also see the control pads on the front. And these are very important because this is what's going to be able to control the actual instrument. So with these, you can actually connect up to 4 SCR 148 units for a total of 24 positions simultaneously on one actual control pad. And what is nice about that is the scalability makes it less expensive the more positions you want. It's going to have some intuitive data entry and programming that's easy to use and easy to find, and you have a lot of pre-installed methods that you're able to be used ready and go. You can also do customized methods with our system, and that is something you can build on your own and have unlimited access to that as well. There is multilingual support depending on where you're located in the world, and you can do data export through the system, whether it's Excel, text, CSV, and whatever is necessary for your LIMS software. With this system, you also have, and with the control pad, you also have direct access to the archive in real time, and you can also do this remotely through our cloud-enabled system, VELP Ermes. And finally, the system is also GLP compliant, which is very important for many labs in today's day and age. So one thing I like to mention with our SCR 158 is our titanium condensers. And these are proprietary to VELP, and this is something different than anything else in the market. And the main idea being that it's going to drastically reduce the cost per analysis, as well as having higher performance. Now, with this, the big advantage is there's no need for an external cooler because it can be up to 20 times more efficient than glass. And what you're going to get through that is more circulations and oftentimes a faster result with titanium condensers. You also have a high recovery rate, as we talked about previously, greater than 90%. Usually we see about 95%, thanks to the condensers, seals, and internal tank, all aimed at reducing your cost of consumables. And this, like I said, allows for reduced consumption of solvent and minimal cooling water, thanks to that water flow control technology. So going into our SCR 158 automatic extraction side, we have 5 steps through hot extraction, and I'll go through each one of them individually, but these are immersion, removing, washing, recovery, and then cooling. So to start off with, let's talk briefly about immersion. So the thimble containing the sample is immersed directly into that boiling solvent. It is lowered in the system. And this is actually the most effective step of the analysis, where more than 70% of the process is completed, whether it's defatting a sample or trying to separate different PET and plastics and things of that nature. After this, we then move to the removing step. And during this removing step, part of the solvent is automatically removed from the extraction cup. And then the level of the solvent is automatically lowered below the extraction thimble, as you can see from the picture. And part of the solvent is then recovered in the recovery tank, starting that recovery process, while the rest continues to flow through the sample from the top, as you can see with those titanium condensers. After this step, we then move to washing, and the condensed solvent flows over the sample and through the thimble to complete the extraction process. And this step is crucial to obtain the complete extraction and finishes up that last 25 to 30%, depending on your sample type. And finally, we have the recovery stage, which is the last stage of the analysis. And this is when the SER 158 continues to heat and stops the condensed solvent from flowing through the thimble and drives it to the internal recovery tank. And this is an important step where more than 90% of the solvent is recovered in that internal recovery tank, and you can use it again for future analyses. Now, after this step, it then moves into the cooling phase. And that is where the SER 158 automatically detects the endpoint of the analysis and switches off the heater. That can be done through an official approved method or through a custom method, depending on your sample type and application. And what's important in this step is the glass cups containing the extracts are lifted up to prevent burning, so you're able to get an accurate reading on your final analysis. And as I mentioned in the previous slides, that automatic solvent recovery is really important for overall cost of consumables. And you can see in the picture here that internal solvent recovery tank with cooling, and it's also going to help cool the system in that sense. So I guess to wrap things up with our SER 158 series, it's a very versatile instrument. You have different types of samples that you can use in different sizes, whether it's extraction cups, thimbles, and seals, to get that desired application. The safety side of things is really important, and through SafeEnd and Safeguard, you can ensure that whoever's operating the instrument will be using consumables in the appropriate way, and they're not exposed to any harsh chemicals. And from this, you can also see the process status LED. You're able to see where the analysis is in the process, and if you're seeing anything, you'll get any warning signals that there could be an issue wrong. And that internal tank with cooling is something we've already mentioned. And lastly, the instrument is smart and intuitive. So with that 7-inch control pad, you have total control of the process, and you're able to see your unlimited library with all the performed analyses, and you can export those at any time. You have pre-installed methods that follow official methods, as well as custom methods that you can create on your own, depending on your analysis needs. And from here, you have direct access to the archive, and you can also do this remotely from our VELP Ermes platform. Now, for solvent extraction analysis, there are actually two different types of analysis. Quantitative is just the total amount of extracted matter gravimetrically determined, and that'll oftentimes be used for various food and feed products. And qualitative is more of a pre-treatment step. And this is the extracted matter is further analyzed to identify the components of the extract. We see those a lot of times in textiles and plastics and applications of those in nature. So now I'd like to bring it over to my colleague Paola at the VELP lab, so she is able to show you more and actually demonstrate the instrument.
Now we will focus to quantitative extractions. So for the quantitative analysis or gravimetric analysis, we can perform both crude or total fat determination in a lot of samples. Now we will start to see some examples of samples that belong to food and feed industries. Here you have a list of samples, for example, the dairy products or meat and derived products, oils, seeds and nuts, creams, different salad dressings, eggs and derived products, and feed, generally speaking, feed for animals. Then there are some other industries where we can perform the quantitative determination. For example, in the environmental industry, we have the possibility to determine the oils and fats in water and wastewater samples. In agriculture, for the hydrocarbons determination. Also in the chemical industry, for example, studying the PET, so the plastics or recycled plastics, and also in the textile industries, for example, for the oil determination in the style or synthetic fiber. Let's start from an example belonging to food industry, specifically to meat industry. It's a salami product, is a crude or cooked meat that we can obtain after a long period of seasoning, where we have the addition of some fat and several kinds of spices. It's a solid sample, so in order to analyze it with VELP SER 158 solvent extraction, we need to grind and homogenize the sample. As you can see from this slide, it's a gravimetric determination. So in order to know the fat content on this sample, we need to weight the tare, to know the tare of the extraction beaker before starting the extraction process. Then, after the extraction process, we will weigh again the extraction beaker with the fat extracted from the sample inside, and knowing the sample weight, we can calculate the fat percentage contained in our sample. All the analysis work are performed in accordance to official methods. In this case, for meat industry samples, we work in accordance to the reference methods like ISO 1 and AOCS. Another important product belonging to food industry is a mayonnaise product. Mayonnaise is a cream, is a salad dressing, can be white or pale yellow cream. Usually the mayonnaise that you can buy from a supermarket contains between 70 and 80% of fat. But nowadays, in order to meet the demands of healthy consumers, the industrial company, the food company, try to reduce the fat content of the mayonnaise. So the solvent extraction technique is very important for the nutritional labeling in order to know the real fat content of the sample. Also in this case, we perform this analysis as a gravimetric analysis, and according to an official reference method that is the AOCS 1. In this case, we were perfectly in the range declared by the nutritional labeling of the sample. Another very important industry is the feed industry. The fat in the feed products is a very important ingredient for the animals, because it can improve aeration of palatability, and also we can see that can enhance the rebreeding success of the animals. We analyze in this case different feed samples that belong to a BIPA organization. BIPA is a European organization that performs proficiency tests, and so every month we receive different feed samples and with unknown fat content, and we analyze these feed samples with VELP SER 158 in order to know the fat content. And every month we fall in the range declared by this organization. In this example, we analyze different type of feeds, and we were in the range declared by the certificate of BIPA. Another industry is the textile industry. So the quality inspection of textile products is very important for the manufacturers of these textile products, and because they need to have a very high quality product in order to improve both the productivity and to meet also the customer demands. At the same time, the manufacturer need to reduce the cost related to the quality issues of this product. So the Hot extraction is required for this product in order to know, for each sample, the oils content added during the manufacturing process. In this case, we analyze a sample of textile in order to know the oil content, and the value should be below 0.5% in order that the material reaches the quality control of the manufacturer. Another important industry for the gravimetric determination analysis is the plastic industry. Plastic or also recycled plastic materials are known for their durability and versatility. These materials are analyzed in order to evaluate, for example, the presence of different components like glue or organic substances. So in this case, we analyzed a recycled PET in order to evaluate the best fitting cleaning line for this type of plastics. So let's move to qualitative extractions. For qualitative extraction, the unit SCR158 is used as a preliminary step for further analysis. The most important industries are the following: the environmental one, for example, for the pollutants determination like PCB, DDT, dioxins. In the agricultural field, for the PAH determination, the polyaromatic hydrocarbons in different types of samples. In the chemical industries, for example, for oil and lubricants determination, and also in this case for the textile industries for determination of colorant used on the production of this type of sample. As an example, in the environmental industry, for the qualitative determination, we analyzed the PCB. PCB are contaminants of the environment and are considered bioaccumulative in the environment. So in this case, we perform the extraction, the solvent extraction using VELP SCR158 as a preliminary step, followed by other two important steps that are the purification step and the analysis in GCMS, or can be also in performing HPLC. These analyses were performed with the support of the CNR, the Water Research Institute in Italy. So let's see some examples of the results obtained on this type of sample. We analyzed two different types of certified sediment material. The first one was fresh water sediment, and we look for finding in the PCB and its congeners. And the average value found in terms of nanogram per gram would fall in the confidence range declared in the certified material. The same was for the other certified sediment analyzed, it was the clay soil. Another important industry for the qualitative determination is the agro industry. We, in this case, analyze cannabis sativa. Cannabis sativa is very important in the medical use and for patients with a variety of conditions. For example, in this case, we cooperate with the American industry that use this type of sample in order to help people with stress disorder, cancer, or glaucoma, and degenerative neurological conditions. The most important parameters in this type of sample are THC and CBD. So it's important for the consumers to know the levels of these two parameters in order to know the influence and effects of this product on the consumer. We performed extraction using the solvent extraction unit. followed by the HPLC analysis in order to know the content of THC and CBD. And we performed analysis in accordance to the official method for this type of sample. Okay, now we'll move to the demo live of today using the SER 158. In the second part of the webinar, we will focus on the best practices and most common steps for solvent extractor analysis. And then we will see how to set all the parameters needed for the analysis. As introduced here before, here we have our VELP SER 158 solvent extraction unit. This is the 3 positions model. We have also the 6 position model. Through the use of this frontal control pad, it's possible to set all the parameters needed for the analysis and to perform all the checks on the unit. Now we will focus on the analysis step. The first step for the solvent extraction analysis is the sample preparation. Here I have a feed sample. It's a turkey feed sample that we receive from BIPA circuit, the proficiency testing product. We receive it as a pellet, and in order to analyze this sample with the solvent extraction unit, we need to grind and homogenize this sample in order to obtain a fine particle size of sample in accordance to the official references methods. Today we will put this sample inside a standard thimble. We have 2 different types of thimbles. The cellulose one that we will use today. The cellulose thimbles are mostly used for quantitative analysis, and we have also the glass fiber thimbles. These thimbles are used mostly for qualitative analysis in order to not have contamination when you perform further analysis after the solvent extraction analysis like GC or HPLC. We have 3 sizes models of thimbles available. The small one, like this one, the bigger one, like this one, and the standard one. Today we will use for our feed sample the standard one, and there are the correspondence extraction beakers for each size of thimble. And today with the standard thimble, cellulose thimble, we will use the standard extraction beaker. In front of each beaker, we have a barcode. This barcode can be scanned with VELP barcode reader in order to send data directly to the SER 158 control pad. The use of barcode is very useful in order to help the traceability of the data and regarding the fat or the extract that we obtain during the solvent extraction analysis. In order to set up the devices that can be connected to the solvent extraction unit, for example, the barcode reader or also the balance, in order to send the weight directly to the unit, we have to enter in the control pad setup. Then here we have to set connectivity, and we have the possibility to select the balance. In this case, we select yes. Here we have a list of balances available for entering the weight directly from the balance through the control pad. Here today we will select the first model available. Then we go back and we will set also the barcode scanner. We set yes. Okay, so we have connected all the external devices of the unit. Now we will set all the parameters needed for the analysis. So let's go inside the analysis menu. We have the possibility to select the method. If we go in the method, we have the possibility to choose between standard methods or customizable methods. If we go in the standard methods, we have a list of methods that regarding different type of samples that I can select for my specific sample. For example, if I have nuts, I can select the method number 5, total fat in oily seeds and nuts. Today, I have already created a customizable method. I enter the name of this method is turkey feed. That is the sample that we'll analyze today. The display shows all the parameters needed for this analysis. So the first is the method name. So we wrote the method of the sample that we need to analyze. Then we have the possibility to enter the official reference. It is the reference to the official method that you have to follow to analyze this specific sample. Then you have the possibility to enter an indication about the weight of the sample that you need to be used for the analysis. For the turkey feed, we will use around 3 grams of sample. The weight of the sample depends on the fat content that we expect to obtain from our sample. Usually for turkey feed, we will obtain around 4 or 5% of fat. So 3 grams are the correct weight for this type of sample. Then I have the possibility to choose the extraction cup. This is the type of the extraction cups in terms of dimensions that we need to use. So if we enter here, we have the possibility to select one of these extraction cups among small, standard, or large one. Today we will use the standard one. Then we can select also the thimble. We have the possibility to choose between different type of thimbles, small, standard, and large, and also the possibility to choose the crucible. If we need to perform, for example, total fat determination, we need to perform the hydrolysis step before the solvent extraction analysis. In this case, we will use the VELP hydrolysis unit HU6 that requires the use of crucible. Then we can go directly with the hydrolyzed sample containing the crucible in the solvent extraction unit without transferring the sample in the thimble. We can use directly the crucible from the HU6 directly to SER158. Okay, now for the today analysis, we will select the standard thimble. Then we have the possibility to select the solvent type. We have different types of solvents available for the different types of samples. Here we have a list, and today we will use the petroleum heater for our sample. Here you have a table with the indication of solvent name. In this case is petroleum heater. Then we have the heating level, is number 3. The heating level is related to the solvent used. Then we have the suggestion about the gaskets. In this case, for petroleum ether, we need to use the Viton gaskets. We have 3 gaskets available. The first is Viton, then we have the butyl, and then the type of gaskets depends on the types of solvents that you need to use for your sample. If you have a mixture of solvents that require different types of gaskets, we can propose as an optional accessory the Vaflon gasket. Then you have also the indication if you need boiling stones during the analysis. In this case, for this type of solvent, it's not required the use of boiling stones. So we go back to the method. We have the possibility to enter also the solvent volume. The solvent volume depends on the extraction beaker used for the analysis. In this case, since we will use a standard extraction beaker, we will load 100 ml of petroleum ethers as a solvent. Then we have the possibility to enter all the time regarding the different steps of analysis. The immersion step, removing step, washing, recovery, and cooling the step. So I have already entered all the times for these steps, so we can confirm our method. And we go back to the main window, to the analysis setup. We can write the operator name. In this case, for example, we can write VELP and save the name. Then I have all the positions selected. In this case, with the 3 positions model, I can also choose to analyze only one sample, so to select only one position, because each position is independent from the other one. If we go in details, we have the possibility to scan the barcode of the extraction beaker in order to enter all the data regarding the analysis. So now we will take our extraction beaker. We will place the barcode that we have in the front of the extraction beaker in front of the barcode reader. Okay, the barcode of the extraction beaker was sent in automatic way to the control pad, and now we will place the extraction beaker on the balance. We need to know the tare of the extraction beaker, because as we explained you before, it's a gravimetric determination, so we need to know the tare of the extraction beaker. At the end, we will know the weight of the extraction beaker plus the fat extracted from the sample, and knowing the weight of the sample, we can calculate the fat percentage contained in our sample. Now we will send the sample weight from the balance directly through the control pad. Okay, now we have already entered the weight of the extraction beaker. And now we will enter the sample weight. So we will take our thimble. We will place the thimbles on the balance using this device, that is the thimble weighing cup, that is useful for holding the thimble during the weighing step. Then we will place the thimble. We do the tare, and then in this case, for the analysis of turkey feed, today we will use about 3 grams of sample. Okay, now we weigh about 3 grams of sample inside the thimble. Okay, then we will send the weight directly from the balance to the control pad. Okay, so now we press continue, and we have all the lines filled with all the information regarding the sample. We have all the 3 positions selected with the type of means that we will perform the extraction. Then I have the cup ID, that is the barcode that we have on the extraction beaker, sample name, the tare of the extraction beakers, and the weight of the sample. Now we go back to the analysis setup. Now we send all the information to the control pad. Now we will place our thimble inside the extraction beaker, and we will place all the extraction beaker with the thimble and the sample inside the extraction unit. Okay, now we need to fill the solvent inside our extraction beakers for the analysis. So we go in the main menu, setup. Then we select analysis options, and we have the possibility to choose if we want to add the solvent in automatic way or in a manual way. In a manual way means that we add it manually using a cylinder where we load the solvent into the cylinder and from the cylinder directly to the extraction beaker. In order not to be in contact with the solvent, we can decide to add the solvent in automatic way. So we select automatic, then we go back to the analysis setup. We confirm the method with all the information that we set before, and now we are in the window for the loading of the solvent. Now we press fill. The system is closing in order to add the solvent directly into the extraction beaker. Okay. Now we will add the solvent in the first position. You can see that we have the solvent coming through from the bottle through directly the extraction beaker. Okay. Once we have filled the first position, we will select the position. And so in automatic way, the tube will be connected to the second position. We will repeat the same operation as we do before. Okay. Okay. Then we will go in the third position. You can see that the solvent now is loading in the third position. Okay, now we fill also the third position. So we confirm that we have filled all the three positions, and now we confirm this step. So we are back to the main window of the analysis. So all the parameters for the analysis are set. Now we are ready to start the analysis. In this case, we will not start the analysis because the unit is not connected to the tap water. But once we press start, the unit will perform in automatic way all the steps of the extraction analysis. The current step that the unit is performing is highlighted in blue and is underlined with the relative ETA, estimated time of arrival, as a countdown. And also the ETA that you can see from here, from the control pad, will change. So the instrument will automatically perform all the steps until the end of the analysis. When the analysis is finished, I will take the extraction beaker with extract inside, and I will place the extraction beakers inside the oven in order to make the solvent evaporate. Then I will place the extraction beaker in a desiccator in order to reach the room temperature. Once the extraction beakers with extract reaches the room temperature, I can perform the weighing on the balance. So I can scan again the barcode on the extraction beaker in order to send from the balance the weight directly to the control pad. We will go in the window of the results, where we have the possibility to fill all the columns, and in this case the total, the column indicated with the total, using in this case the balance, and then by pressing calculate, I can obtain the percentage of fat contained in my sample. If I press save, the results will automatically saved in the archive. In the archive, I have the possibility also to calculate the statistical data in terms of average, standard deviation, and the reproducibility, both in grams or in percentage of fat. And now we can conclude this demo part of this training. Thank you very much for your participation.
Thank you very much, Paola, for the detailed demo there at the VELP lab. So I wanted to go over a few questions. If I don't get to your questions, always know that you can reach out to marketing@velp.it, and we'll get back to you as soon as we can. I'm seeing here one of the first questions asked was, what is the sample weight and what are the allowances for that? How big can your sample be? In short, your sample range can go anywhere from 0.5 grams all the way up to 15 grams per position. Now, with that, the caveat being there's different densities, there are different types of samples that will require different official methods, but what's important to know is your sample type, and then from there we can go into different thimble sizes as well as extraction holders and then cups. So if you have any specific questions about your application, please feel free to reach out. Another question I'm seeing here is what types of solvents are allowed with the system? In short, if there's an officially approved method that is compliant with our system, the solvent will work. And as you could tell from Paola's demonstration, there are many different solvents that you can choose from depending on your application. But if you have a specific application question or specific solvent question, please feel free to reach out and we can address that for your specific sample. And then one more question here. They asked about cloud connectivity and what that looked like. So I didn't touch base on it a ton at the beginning, but VELP has a cloud platform called Ermes. And this cloud platform allows you to access your instrument from wherever you are via any sort of smartphone or smart device. And you can control it, stop analyses if you see something wrong. And you can also export your data remotely, see it at any time, at any place. So, in terms of connectivity with the instrument, it's a really good benefit to have. And somebody, whether it's quality, R&D, even people can look at other technicians' work and see how their lab is progressing. So I think that wraps up all the questions and all the time that we have for today. But thank you all very much for joining the webinar. I appreciate all your times. And of course, if you have any questions, like I mentioned, feel free to reach out. Thank you.